Good morning, Hacksters. It's my favorite day of the week. It's Hackster Café. We get to talk to, this week we're talking to Rodney Trusty, who is a maker, a creator of wearable technology, and you also share a lot about your process and stuff, but also the founder of Digital Fiber, which would you call it, like a wearable tech studio, manufacturing design?
I guess you'd call that a wearing tech studio.
All kinds of cool stuff that you're doing. So you're doing this, actually, I would love to learn a little bit more about your backstory because I started seeing your stuff maybe a year-ish ago, and
Mhm.
I hadn't really tracked your story before then. I'd love to hear about how you got into wearables, whether you studied it, whether you picked it up on your own, like, did you do business? Like, yeah, what's the Rodney story?
All right. It started. I was doing construction, mid 20s, and I never really liked construction. I'd worked in it for a while. It's a good career, and I was looking for a change around the time my son was born. So I pretty much Googled what can I teach myself, and I came across embedded engineering. So I put all my time and energy and effort into learning that, and then eventually transitioned through a collection of projects that I built up. I went door to door asking for a job, showing the project, saying this is what I could do, and then I eventually got into the electronics industry professionally. And then from there, my side projects continued because that was my method of learning, just coming up with more new projects. And eventually, I got to the point where I was trying to get LEDs into a pair of shorts with an
Mm.
accelerometer on it, so when a person dances, the lights move as well. And I originally did that with LED strips, and that was just impossible. I couldn't. There we go. So you see those
It's
those
amazing.
LED.
You got some YouTube stuff on there too. It's controlling a little car, right?
Yeah, so that one has the accelerometer data going to
Amazing.
the RC car as well. So the
Oh, the
challenge
little
there
car.
was those strips fall off easily,
Uh-huh.
and and that was the motivation there for getting into e-textile. I saw that it was a bigger problem than I had originally anticipated, and as I started going down that rabbit hole, it unlocked a whole bunch of other different discoveries as well.
Yeah, and since then you've definitely come up with a lot. Not only have you made a bunch of upgrades to your process, but you're sharing those all the way along the way. So just to dive into one of the things that you mentioned you brought today to show, you've mentioned about, for example, the difference between castellated and round edges on your PCBs, and this is obviously a feature of many wearables that we see. And I'd love to hear your thoughts on that.
Sure. Yeah. So one of the challenges, as anybody who's sewn textile circuit has run into, is that when it's disturbed, moved around, or when it's washed, it loses connectivity. And that is usually the electronics usually survive the wash. It's usually the lock stitch itself that comes loose or breaks away, or loses contact, and then that screws up your circuit. So one of the major differences, if you that board you just showed, the lily pad. It's round all the way around, and on the edges of the board is non-conductive. So as you weave in and out of that PCB hole, you don't have contact on the outer edge of the PCB. So you've lost 25% of your contact there. That's a very significant difference. So one of the solutions to that is to have castellated edges, as you see here, if I can line that up, that dip
Mm.
inside. If you weave in and out of that, what that does is ensure that no matter which way this PCB moves, it always maintains contact on one of its sides, more of its sides. Um, and that drastically increases washability with a number of other tricks as well. For example, you never just sew one line of thread from one component to the next. You always need two or more. Sorry, I'm dropping my material here. You always need two or more. Actually, now that I'm here, this actually was
Ooh.
one of the first that I designed. I don't know if you can see
Wow.
that because of the poor lighting, but that's actually a game displayed. Actually, I'll
It
get
looks like
into
a
that
Space
later. But
Invader, kind of.
Space Invaders, yeah. So you can connect with your phone. Let's see. I'll pull it up now since we're here. You
Haha.
connect via Bluetooth, and give me 1 second here. And sorry, it's taking a little minute. and you can actually control these. So I learned actually from this project, if you can't see on the camera, but the LEDs towards this end are a lot dimmer than the ones on this end, and that's due
Ah,
to the issue of only having one trace of thread. You always want to go back with two or more traces to increase conductivity and reliability through machine wash. So this has actually been washed probably more than any other the project I have, and it still works after about 3 years. So I can show you here
nice.
on my phone. I can connect and play, and this is all machine washable as well using those techniques.
That is so cool.
So,
Oh, there's a couple different things I'd love to dig into here. So on one of your recent Instagram posts, you talked about what you were just mentioning with you never sew just one uh, layer, I guess, of or iteration of routing in any given trace, and you've
mhm.
come up with now these terms. Are these ones that you're inventing for these situations that are new to wearable technology, or are you getting them from somewhere?
Yeah, I thought my sister is or was a licensed cosmetologist, and
Wow.
these are terms from her field. So there's a track, a frontal closure. Those are terms for hair. That's
Huh.
sort of adopted because they fit pretty well. People who are into that would read those and instantly know. But the reason for the naming was because I think I mentioned to you before, I have a custom CAD software, and these components are programmed into it as such. Um, for example, if you look at the track, it says a bundle composed of highly conductive traces designed to carry high voltages. The thread used in that track is different from the thread used in the frontal because the high current carrying thread is very expensive, so you want to minimize it, and you only want to use it for the main power bus. So that's why there's a need to have some sort of terminology, and try and develop some system where when we're speaking about it, everybody knows what we're talking about.
That makes so much sense. This custom CAD software thing is blowing my mind. I'd love to hear a bit more about that. That's listed on your digital fiber main page, and this is the your company that you run, where you do consulting, you do hardware, software, and manufacturing. And here it says it's a desktop CAD program. Yeah, could you please tell us a little bit about that?
Sure. So if you've ever used traditional embroidery software, it's really good for graphics, but it's horrible for circuits because when you're dealing with circuits, you want to avoid thread cuts in certain places. You want to avoid your top or bottom thread running out in certain places that could cause shorts. Sorry. Whenever the
Hmm.
thread is cut, it leaves a small tail that frays, and it'll break off really tiny pieces of conductive fiber that you can't see. And good luck finding if there's a short circuit.
Hmm.
So the circuit has to be routed in a very specific way for to make it one work period, and also to minimize the amount of human labor that is going to have to go into post processing it. Um, Modern embroidery software optimizes for graphics and it works against you with circuits, and that's why I felt the need to create a custom solution to that. Another thing that it has is a design rule check where modern embroidery software is probably never going to integrate. um, that forces things, for example, like 45-degree turns, keeps signal traces a certain distance from one another. It balances how
Hmm.
much of the expensive thread to use versus the cheaper thread for the frontals, and it also ensures that you never actually physically bring your needle down onto a solid piece, which I've done many times, broken metal needles and had to deconstruct and reconstruct my machine. So the
Wow.
software was made to speed up that process. Another thing it does is it has auto generation for matrices. So I'll give you an example. Here is a pressure cell matrix. Each of these individual squares is a pressure cell, and this is actually
Wow.
two layers. So there's a layer of coils on the top, and there's a layer of coils on the bottom, and there's eh, I don't know if you can see here. I wouldn't be able to see it, but there's an interposer. There we go, on the
Oh,
back
there we go.
that
Yeah.
connects the matrix to this connector for prototyping. All of this is generated by just entering 4 by 4, two coils, and each square X amount of width. Automatically generated. If you were to do this in modern software, it would take a very long time because you'd have to manually route these coils, make sure they're not too close to one another. And again, this is more than one trace. It is going forward and then it's tracing itself backwards. You have to worry about that. You also have to program in when that make the machine stop. It's a lot of different things. So the program will export this design and also export instructions on how to actually assemble it. And the ultimate goal there is that digital fiber will educate a manufacturer and provide a tool to a creator so that when the creator creates whatever they create in Digital Fiber Studio, they send it off to the manufacturer who's been educated how to run it, and they make the exchange using the tools, and I step out of the way. So there's also auto generation for this is a Charlie Plex circuit.
Uh-huh.
This auto generation for a this is a matrix circuit, which is a little bit different than Charlie Plexing, and also LED strips of any configuration. So you can go in there like Microsoft Paint, click around a line of any shape, and then instantly turn that into an LED strip and run it on your machine. So it saves a lot of time.
Wow, that is so many tools in one. I've done a little bit with embroidery machines back in the day, and even just getting this thing, this was like I dissolved the antenna and chip out of a transit card and sewed it into a
Yeah.
thing. And even on that, like I broke my needle because the I think the satin fabric caught on it or something, and just like
Hmm.
you're putting entire PCBs in here, and I know that some of them are flexible ones, and but some of them are clearly rigid. And like that thing that you
Yes.
mentioned about how it knows how to like not hit solid objects. I was wondering, yeah, whether you like added those later by hand or what. Could you tell us a little bit more about that process? That's so fascinating.
Yeah. So part of the process is when you're embroidering your circuit, naturally you're going to pull the material one side or the other if you have a lot of stitches on one side. So you
Oh.
have to route in a way that one evenly pulls it. But another thing I do is after I've run all of the base circuit before the LED gets put on, I then do a placement stitch or put a little box around where that LED is supposed to be. So if the machine has moved, it doesn't really matter so much. The LED is where the machine believes it's supposed to be at that point. And then you place the LED down, and then it runs the final sequence of tying it in. Um, yeah, so that's how that process works. It is manual, and one way to reduce that manual labor is to have the PCBs design in a grid and slap them all down, or things of that sort. But at the moment, it is a one by one uh, manual process.
When you're using flex PCBs, would the machine, do you think, be able to tolerate, like, I guess it depends on the machine, but like the stitching through that? Obviously, that's not the way you're designing it, but
Yeah, so I did switch to flex PCBs for a lot of designs. So this connector here is actually a flex PCB. And the reason for that was just as you mentioned, if I miss the hole, I want to puncture. I don't want to break my machine. What I found though is flex PCBs are harder to work with because they're so thin. So it's really hard to get that solid connection uh, maintained between the thread and the PCB. That's helped by first sewing a trace underneath of the conductive of the PCB pad and then sewing it in. But the thin profile is difficult to work with. So I kind of accept the challenge of trying not to crash into the hard PCB above the challenge of trying to make the flexible PCB work.
yeah, that makes total sense. I'm curious, because I think a lot of people go for flexible PCBs with fabric because it flexes seemingly around the body, but yours are small enough that you're working around sort of the rigidity of the PCB. And how I'm coming up with the word feelable, but I think that's just because I'm low on sleep. Like, how much can you feel the PCBs when you're wearing the garment, or like feel the LEDs?
You feel that something's there, but it's kind of like you're putting LEDs in your fabric, so you're gonna feel
Sure.
something. It's not obnoxious. And same with the flexible. You feel something's there, but it's not an obnoxious feeling. My fear with the flex PCBs is that they could just be torn off if you pull them hard enough. So one thing I do with
Ooh.
those, you can't see them here. This is exposed just so you can see how it works. But I'll typically cover over them with a satin stitch or just cover it completely with normal thread. And that keeps it locked down and that keeps it safe from abrasion and that kind of thing and being ripped off. And that works well enough as well as it needs to.
Mm. You've got this, not just t-shirts and things, but you've got this sort of haute couture dress
Ah,
situation that you
yes.
made for a murder mystery. This is just gorgeous. And I'd love to hear ways that you went about making this a sort of, I guess, more polished
Hmm.
garment for a client, and how that differs from your prototyping process. It almost looks like it's
Yes,
brown thread. Is that the satin stitch on top like you were talking about? Sorry, I
yes.
interrupted.
So those are, yeah,
Mm.
those are covered with the satin stitch and they're insulated. So that's another washability tip. Always insulate your traces. These conductive threads, if you so much as rub your finger across them, they lose conductivity. So that's
Ah.
important. But this was that project. Alan Gonzalez, a designer up in New York, that was his brainchild. So he envisioned it and laid it out, and I created the circuit from it. So I got to give him credit for that. At that point, I had never done that type of circuit. The traces you see are going down her stomach are going to the controller hidden inside, and it's a matrix. That was a very challenging project because the first time I'd done that, if you can see, even the LEDs are not as bright as they could be because I didn't do multiple passes, as I just mentioned, helps a lot. But it came out really beautifully, and that was like the first time I got to see the project done something on something more complete.
Honestly, this is
Yeah.
totally
We're
gorgeous.
we're actually working on another project now that I'm going to finish up today. Do I have
Ooh.
it anywhere around here? So this one, every time I work with him, he gives me a challenge. So if you work with conductive thread, one of the biggest problems is conductivity, oddly enough. So a strip like this, you might start at 5 volts here, and then at the other end, this is only about a foot. You might get 4.5 or 4, and you might have about 100 ohms or more of resistance just between this length right here. That doesn't work for addressable LEDs. You can't have a whole volt or 100 ohms between LEDs.
Mm.
So the project we're working on now has about 7 feet of trace. It's a dress, and the power goes around the perimeter of the bottom of the dress, and it's about 7 feet of traces. And we've been able to get it down to less than half an ohm throughout that whole 7 foot length. So I love working with him because he always brings something to the table that I haven't done before. Another thing is the dress is huge. My machine can fit a square about that big, so I have to rehoop it 4 times and align each pattern with the previous one to get that perfect circle going around. So yeah, that's just
Ooh.
some of the challenges that it come from working with him. That always it takes my game to the next level. And now I have capability to do even more.
Yeah. And you mentioned rehooping. For people who aren't familiar with embroidery, what does that entail?
Okay, sorry, yeah, because I just learned about this myself too with this project. So rehooping is when the pattern is too big for your machine, and you have to take it out, move it over, and then run the second. You have to break your pattern up into squares, and then run each individual square. So it requires you to align when you take the fabric out of your machine. It requires you to align it perfectly to continue the pattern on to the
Mm.
next square section. And in this case, it had to be done 5 times, and
Oh,
we got it
wow.
done, and it looks really nice.
Oh, nice. Is this sort of like along the hem of the skirt? Is that why it's like 7 feet long, or is it?
Yep, it goes along the
That's a
bottom of the
pride
skirt,
touch.
and then it branches up into flowers or astrocytes that have which are like special looking brain cells that look like flowers. It's for a STEM fashion show, and they each have
Wow.
LEDs in the middle. So they stem up from that trace going around the edge, and that's how they power it, and that's how they receive signal as well. So the challenge is having that signal go over such a long distance. Even in traditional electronics, you always keep your signals as short as possible. You keep your components as close as physically close as you can. It's a real challenge scaling that up to 7 feet in fabric, but it worked out.
Yeah. Wow. I cannot wait to see that. That sounds amazing. Also, I love that you're putting the stems in STEM.
Yeah.
um, so you mentioned just obviously like the working with fabric. I'm curious of how you work with like the inherent stretch and flex. Are there specific fabrics that you choose to work with? I noticed that you've got some sort of zigzaggy patterns in here, which is one way that people deal with stretchy, like sewing on stretchy fabrics. But yeah, are there tips for like material selection? Like,
Yeah, so in this case, the zigzag patterns is just because I didn't want to use boring straight lines.
it does
I
look
hadn't yet
awesome.
I hadn't yet figured out how to get the LEDs in there without the traces showing. So at the time of doing this, that was like the alternative. If I had to show the traces, they were going to look good. But to answer your question with stretchy material, when you're actually embroidering, what you want to do is you can use a spray glue of your stretchy material onto a
Hmm,
non-stretching substrate. And then I usually use like a dissolvable interfacing, and you can glue it on there. Or what I do whenever I go to place a LED or a component that I'm concerned with its placement is you do an underlay stitch. And what that underlay stitch does is it locks that portion of the flexible material to the underlying interfacing. For those who don't know what interfacing is, that's another layer of material that you apply with your fabric that you're embroidering on to keep it stable. So as long as it's adhered to that stable fabric, the stable interfacing, you're able to embroider it just like you would any other. The main
nice.
concern that I've run into is the thickness of the material. You want a thicker material than a thinner one, and then when it's done, if you have the dissolvable interfacing, you just run water over it, it disappears, and now you have your stretchy LED fabric. But of
That's
course,
so
you do have
magical.
to. Yeah,
Sorry,
absolutely.
go
And you want to zigzag as well. So you don't have to do huge zigzags. You can do a bunch of like 3 millimeter, 4 millimeter zigzags, and that'll give you enough to stretch a good amount.
awesome. Let's talk about your technical preferences. What kind of a machine do you use for embroidery?
I use it's a ZSK Sprint 7L. So it's like an industrial size embroidery machine. It's pretty big. It's got a 18 needles. The reason I use it is speed and accuracy. So it can run 1,200 stitches a minute, and it is accurate to within a tenth of a millimeter. And I export all of my designs with a half a millimeter tolerance, and it holds them pretty well. Like I've never had a machine crash unless I made an obvious mistake. It's never been due to the machine. Another good thing about this particular machine, and they're not paying me to say this, I just like the machine, is it's very workable. So I've been able to open it up and go in and replace certain parts to make them pass the more troubled threads easier. So there's like a silver coated thread that I use very often, that is very difficult to pass through any embroidery machine. But I've been able to go in and for example, pop out a plastic insert and replace it with a ceramic one. Do funny things with the bobbin case to reduce tension there, and have been able to make it work. And that's just because this machine is just open. Yep, there we go. Is very workable.
Cool. I love that you're hacking the machine at the same time as you're using it to hack fabric.
Yep. This
So
company
cool.
actually does, if anybody's interested, they do textiles as well. Um, so when they got sight of my that I had one of their machines and what I was doing with it, they actually sent their head of director out to my house, and we worked together in the garage. She gave me a lot of cool tips on how to use the machine. Some design rules with circuits. That actually was like a turning point. It stepped my game up, like a couple of steps, and then led down all sorts of pathways. So ZSK is a really good resource, though the machines are not, I guess, hobby level. If you'd have to really be
Mm,
serious about it if you wanted to go that route.
absolutely. We have got a comment. Yeah, so many of these techniques that you're sharing like are completely man. I would love to know some of these a while back, and it's amazing how much you're sharing about your process. Like this one that I pulled up a minute ago because I think it is this
Hmm.
the interfacing that it's showing here as the
No, that's
base.
the LEDs are being
Oh,
sold onto just white fabric, and yeah,
oh,
so that shows how you. It's important to optimize your circuit routing for a number of
mm,
reasons. One of which is for post processing. If you look on the bad side, you see between the data line, which goes in between each LED, and then the thicker middle lines, the tracks, there's a conductive thread touching. Now that's due to me not doing cuts in the machine. So when
mm,
typically in graphical embroidery, you might cut your thread, jump over it, and then start stitching somewhere else. With circuits, it's dangerous to make a cut because that's a potential short circuit. So what you'll do is you'll jump around until you're finished, and then you'll manually cut those loose threads that you see in between the LEDs. Now, when you route, you have to route in a way that when you're finished, the threads you need to cut are all organized. You don't want to have to dig around and try and find them because you're leaving short circuits everywhere. And that's one of the things that the software automatically does. It routes it in a way that minimizes the amount of thread cuts you have to do, and it leaves the thread cuts in places that make sense. If you just go haphazardly designing it, you're going to get a mess that's going to take you 2 hours to clean up when it comes off the machine.
Wow, yeah. That was one of the. It makes me think of like if I were making soldering together a circuit and then I just like left my leads everywhere, and then if I tried to put in an enclosure, they'd all like jam up against each other and cause short circuits everywhere. But with fabric, it seems like nightmarish. Yeah.
Yeah, when you have a short circuit with fabric, sometimes you just gotta throw it away. It's like there's
Yeah.
no way to find it. I've banged my head for long periods of time on some circuits that had shorts. It could just be the tiniest sliver of silver coated thread touching something, and if you have hundreds of LEDs, good luck finding that. So
Mm,
I've definitely tossed and restarted a couple of projects, but now I'm confident enough in the process that I know if I'm going to have a short or not when it comes off the machine, and I know where it might be. So that you have to be very careful about routing for a number of reasons. Yeah.
yeah. Um, I'd love to hear a bit more about how you taught yourself. So you mentioned that you looked up the best trades to learn or skills to learn in order to get out of construction. And one thing that you show on here is back in
Ah, yes.
2019, you were doing this. I'm curious about like A, this design, but also B, like what your process was for teaching yourself, like whether you preferred to learn from YouTube or textbooks or
Mhm.
what.
Yeah, I'm a big reader. I can't do videos. I cannot. It's I don't have the attention
Legit.
span. But so my process was I went on Indeed.com and I typed in jobs that I thought I might want to work, and I sorted them from highest paying to lowest paying because why not? And then I took the top 20, 25, 30 jobs, and I compiled all of what they said was required to work that job. And ordered them in a list, and one by one, I went through and learned each. But I learned each with a project because I didn't have a degree in anything. So I knew if I was going to come and ask for a job, they're going to ask me, well, how do we know you know anything? So every item on that list, I had a project for. One of the first ones was that AirTag thing you just showed. This is actually a newer version of that.
Oh,
Um, so this does everything the AirTag does minus the Apple ecosystem. And so a project like this, for example, I would read that spy. You needed to learn spy or CAN or ultra wideband or Bluetooth. So I just went through each one of those and learned them with the project. This actually came just an idea that I wanted. I was imagining we could have GPS but indoors because GPS in the phone at that time, I don't know if it's gotten better, but when you go inside of a mall or something, it wasn't accurate.
mm.
And I was imagining having these, and you could wear this tag, and you could play like either go karts and follow where you're going, or paintball, and you can know where your buddies were. And that was the motivation for this project. And then it also taught me a bunch of electronics principles. It taught me battery charging. For some reason, you would think you could just go on Google and say battery charging circuit, and then someone will teach you how to do a battery charging circuit.
Sure.
Battery charging is, for whatever reason, was very difficult to find. MCUs, I'm using STM32, and then ultra wideband. And then another thing I learned from this was calculus, because the the algorithm to trilaterate the position of one object from three stationary beacons and also integrate the information from the IMU was very math heavy. At that time, I'd
Yeah.
never involved myself with math, maybe since high school. But I think when you have a project and a goal in mind, um, then learning is just a step towards that. It would be very difficult to sit and learn, let's say, calculus or something in front of a board with no project. But if you have the project, it makes it like like nothing because you have a goal to go towards. And I kind of stayed with that with all the projects.
Awesome. Yeah. Hey, Aisha. Aisha is also another past guest of ours, but yeah, absolutely inspiring. Just digging through all of your posts on the way, like doing research for this is so cool. I'm really curious about another technical detail. So you've made a bunch of different microcontrollers and PCBs, and I'm curious if you have any favorite chips to work with, favorite microcontrollers, favorite programming environments like Arduino IDE. You've definitely got, well, okay, not to take over, but you've definitely shared some Arduino stuff on your GitHub, which people can go find. I'm going to add this to the description, by the way. Everyone go check out the links in the description. But yeah, you've got, um, I'd just love to learn a bit more about your tech stack.
Sure. Yeah. So I almost always use STM32 unless there's a reason
Mm.
to go outside of it for microcontrollers. They pretty much have everything I need. And when I was learning, someone early on, and maybe this was the wrong information, someone early on told me not to bother too much with Arduino.
Mm.
So I didn't. I just went to the next thing I found, which was STM32. And then professionally, I did a lot of work with Atmel chips, which of course, Arduino's from that, and TI chips as well. So I guess my order would be STM32, TI, and then Atmel. And then for processing, uh, pretty much any platform that I use, I have to be able to. It has to be open source. I have to be able to have access to the entire hardware suite. So I don't want this to sound like a shot at Raspberry Pi. I love Raspberry Pi, but when it comes to selecting a device for a project, I lean away from any platform like that where I can't have complete access to the hardware and software stack.
Mm.
So open source or I don't touch it.
Awesome. I did notice also you've got KiCad in your Google here, or Google GitHub. Uh, so is that also an extension of your open source philosophy, or?
Correct. Now, that GitHub is not updated. I'm gonna have to update that. So you guys,
Same. That
so
resonates with me.
the CAD software I'm working on, I learned a lot of that based off again with the open source
Hmm.
philosophy. I learned a lot from the CAD software. They use WX widgets. Now I'm far enough in the project, and I've learned enough about desktop CAD that I probably should have used Qt or something like that. But I did WX widgets because CAD uses WX widgets, and it's moving along now.
Cool. It's just mind blowing to me that you've invented your own software as well as your own hardware bits, and I've got to stop saying that because otherwise it's going to come up like 5 more times. But like, you made your own like mashup embroidery uh, and CAD software for PCBs, or like sort of a mashup of the two. So just for context, people, I was like in maybe 2011, got into embroidery machines, just like a hobbyist. Brother SE400. I ran Indiegogo to get one of them, and it took me 10 years to fulfill the perks. But anyway, anyway, at that point, the state of like open source software for embroidery was very minimal. Like the official software was incredibly expensive, like very like more than the machine itself, I think. And so the
Mhm.
fact that like you're building your own one is like all the stuff that goes into it. It's incredible, and it's
Yeah.
both in one. So okay, words, but
Yeah.
sorry. So is your software open source?
It's not, but it's going to be free to use.
That's
So
amazing. That's amazing.
yeah, you'll be able to use it free. You don't have to pay anything, but the actual code will maybe I'll open source it. The thing I have against open not against I don't want to say that. The reluctance I have is
Sure.
maintaining it for the public eye. I have to
Mm.
fit it to where people can find it useful, and that's another effort. So if I get around to that, I'll do that. But at the time, it's kind of like it's going to be hard to get it to that point.
Mm-hmm. Yeah. And speaking of things that, because you've got so much going on already, like I mentioned, you've got this consultancy, digitalfiber.us, and you're actually doing like design, doing manufacture. I'm curious about, what was my question here? Oh, yeah, just like speaking of things that like people can pay you for, when you're working with hardware with a client, so say with that dress, for example, um, What's the process like? Obviously, in the case of this dress, the person had their own views, and you've mentioned that it's sort of a collaborative process. How often is it that sort of they show up with their own entire design, and how much of it ends up being sort of a collaborative design process in your experience?
Yeah, at the moment, it's always they have their full design. They'll have a pattern, put some marks of where they want the LEDs, or do like a sketch of how they want it. I'll look at it and see, what's possible from an electrical standpoint. Like that dress with the 7-foot trace. I didn't even know we'd be able to do that. I look at it from that standpoint and then tell them if I could do it or not, and then we go from there. The That's how it is now, but the ultimate goal is that digital fiber will be the tools for the creator and the manufacturer, and I wouldn't have any involvement. So, if you're a creator and you want to make your own pattern for a dress, you would use the software, import your pattern, mark it up the same way you would have to mark up something to send to me. You would mark it up in the software, export a design file, and then a manufacturer creates it and sends it back to you. So that's what I'm working towards. Obviously, that's a process.
Mm. And I'd love to get to some of your physical things that you have to show off in your garage. But before that, just really quick, I noticed while looking at your feed that you do these. Is this a Spartan race? Is that what it's called?
Yeah, my sister has me out on those. She's done like 20 something of them. So yeah,
Whoa!
she dragged me out, and it was pretty fun. It was pretty fun. It was a nice activity. I think if you got an opportunity to do something like that, you should do it. The environment is really friendly. Everybody's there helpful. If you can't finish an obstacle or something like that, there's no harm, no foul. Everybody there is supportive. I think it's a really good thing that people are doing.
So, A, super badass. Also, your sister sounds really cool.
Yeah, she's really cool.
uh,
Yeah.
But doing that, did you have any like thoughts about ways that you might make where, because that's obviously sort of an extreme environment. Uh, have you had any thoughts about
Hmm.
like either devices that would help you in that case, or like ways that you'd modify a garment to make it like the ones that you make are already like washable and water resistant, which is really impressive. But like, yeah, in that kind of environment, what are your thoughts?
Yeah, so I've been working on encapsulation techniques for the electronics. So ways to get them coated or sealed to where mud, water, and that thing won't bother them, even while they're powered on. That's still a process, but the idea would be that for something worn, you could have electrodes that are tracking your breathing, that are tracking your heart rate, how much you're sweating, and that kind of thing. And that's really useful for any sort of athletic activity. Uh, One that I've been working on more recently are socks that you wear, and it has this pressure sensing technology woven into the sock, so you're able to monitor weight distribution across your feet with a high level of precision and granularity, and that's really good for athletics as well. So biometrics is sort of where I've been pivoting to. The LEDs, even though they're not particularly functional, are very difficult from a manufacturing standpoint, way more difficult than the sensors. Sensors are easy to manufacture, maybe hard to program, and the LEDs are very hard to manufacture, easy to program. So
Huh.
yeah, I've been leaning a lot more onto the biometrics.
Cool. Yeah, we've been seeing some. I'm trying to find it right now. Some. Where is this smart whole thing? Oh yeah, here we go. At CES this year, for example, and with a previous interviewee at Siren Care, Ranma,
Ah, yeah,
we've been seeing some like stuff for diabetics, where it's like these sensors that help with health monitoring as well as like if people are doing sports. And I think this one was actually like self-powered, which was ridiculous, but. Yeah, it sounds
yeah.
like maybe you've heard of one of these before, or like thought about similar.
Yeah, so that
Uh,
sock or that footprint that they showed is pretty much exactly what I'm
mm,
trying to do with the thread. And the self-charging, so there's a electrical phenomenon. I'm going to mispronounce this. It's called like the Tribo electric effect, something like that. But it has to do
yeah,
with you generating charges from friction. So that's one thing I'm working on too. So like having the inside of your legs or your sides of your shirt generate electricity for your circuit. And I've been evaluating like how far can that be taken? How much energy can we take from the world around us and use that to power your shirt. And you can get like a couple of LEDs. I haven't been able to power a full MCU yet, but I'm working on that as well.
Cool. Oh, I can't wait to see more about that. We have a comment on your, speaking of MCUs, Kamana chimes in
Yep,
about STM32. A great point. Yeah.
absolutely.
Um, so yeah, you've got these examples. Obviously, right behind you is this sort of visual example that you brought up on your Instagram about how far you've progressed from your first experiments with this. I'd love to hear about a bit about that.
Yes, this first one, I was thinking, okay, how do I get LEDs in a way that can be washed? So I had these little PCBs designed. Maybe I can snap one off.
Ah,
And it was just a couple of LEDs on a PCB snapped onto a shirt. This was never going to work. I don't know why I thought it would. And before I even finished it, I was like, "This is taking too long. I'll never be able to produce more than one of these." So I just threw that idea away. And then this is a more recent version. So this has actually the LEDs sewn in the same way they're sewn in here, except it's a larger matrix. And this hasn't been on the washing machine, but its sister has been washed and it still works. And that's sort of the progression. I have a smaller one here that I tried to make for my son, but my sewing skills are not so good, so it didn't turn out too well. But
that looks awesome though. So futuristic. And this is also documented on the Instagram. If y'all are interested, you can go check out this video. Uh, just a little bit more about the progression there.
I missed the hair.
Do you think you'll go back to it?
At some point, it's a lot to maintenance. So, yeah, and these long sweaty days in the garage don't help long hair.
Oh, yeah. So I know that you've gone into this partly because of, you wanted to have something that you enjoyed that was going to be interesting to you, but also, how much do you consider yourself like a fashionista or someone who thinks about sort of, yeah, your own personal fashion?
Not at, I'm so bad with that. So, like my focus and I think one misconception that I run into a lot. People think that I can sew or do anything with fabric at all, and I can't. My specialty is in the techniques and the electronic side, and I defer to other professionals to do anything related to like sewing. As you can see, when I try to sew it, it doesn't. But that's a skill I'll have to develop. I have to develop that.
Legit. You have the fashion skills though. Don't try to lie about that. We see you.
I was,
Anyway. So what else have you got here? You've got some really interesting, like the one that I think is to your right, or possibly to the left, depending on the gesture-controlled LEDs. Is that like an
yes.
infrared interface?
Correct. I'll see if I can get a good
Nice.
camera angle. You'll see some of my old construction hats from the old construction days.
Ah, cool.
So these are. I'll show you the panel itself first. This is a 4x4 panel. It has addressable LEDs, and each LED is paired with an infrared emitter, the clear LED, and a detector. And it emits infrared light. When it gets reflected back down, it's detected by this STM32 in the middle, and then it activates the corresponding light. So this is sort of a larger uh, view of that here,
Mm,
and it's pretty responsive. These
so
LEDs can
cool.
be programmed different colors. It's not fixed to this one color, and they all can talk to one another as well. They have a SPI connection between each individual panel, so they can all coordinate one large game of Pong or Tetris or whatever you want to do there. And that's all programmed. So when you first turn this on, the first thing they do is they all have this massive conversation and identify where they are in this grid. What the size and layout of the grid is and where their place is in it. And then they all report that back down to the master controller in the bottom corner. And then the bottom corner can then direct them um, based off of that. It can request to get their sensor readings, and then it can command them to display whatever you want to program it to display. And this is
Ooh.
actually going to be open source, the hardware and the software on Crowd Supply. The pre-launch page has just gone up. It says it'll be Crowd Supply React
Ooh.
LED. So anybody who wants to know how this works can have this. This was one of the first projects I did, so I just want to make that available for other people who might be trying to learn. Um, and some of the basic things that you would want to know learning is really difficult to find the first time. Like if you have an MCU, just a bare MCU, how do you get a program on a bare MCU? Things like that. Um, the idea of this project is it'll help people with those kinds of things.
Yeah. So I've got the crowd supply page pulled up here. And you've also got a Tindy where people can get hold of some of your creations here as well. So everybody check that out.
Yes.
I'm curious. So is there a difference in working with these two? These are sort of two big maker outlets where people can release their own products. And I'm curious about like your experience working with each of those.
Yeah, so with Tindy is like more independent. You just post, you share what you have, and then you get it out there, and somebody might buy it. I haven't put a lot of effort into that. And with crowd supply, there's more of there's a lot, I guess, hand holding. I don't want to like make it sound like,
Mm.
but there's help and support. That's a better word for it. There's a lot of support there with the team, and it's much more planned. So right now, I have a campaign and I'm planning to roll out, step by step for these LED panels, and even an upgrade. So this will be the upgrade. Instead of being 4x4, it's 8x8, and it uses SMT components, so you can see the profiles much lower. So yeah, I do like that with crowd supply, that the crowd supply team is very, very helpful, and pretty much ready for for questions and assistance almost 24/7. You message them, they get back to you. So
Wow, nice. And they just had their um,
tear
teardown
down.
conference. Did you go?
I didn't. I wasn't able to make it, but
Me neither. Next year, though, maybe.
absolutely.
So here is the crowd supply. If you're on YouTube, I've just dropped the links into the chat. Thanks, Aisha, for the prompt on that. I'll also drop them into the video description for anyone who's watching this later. You can go sign up for updates on the crowd supply page, and if you're interested in the Tindy stuff, you can just go there right now. Just go find those links. And yeah, I'm really curious. When you were putting your arms out over the display, it gave me for a moment like these sort of DJ vibes, and I wonder if you've thought about working with like, uh, you know, musicians.
That'd be cool. Yeah, there is a musician I want to work with. You mentioned his name is. I just said give a talk. Yes, I hope to give a talk there on e-textiles. That'd be great. His name is, and I might mispronounce this, Plexus Play on Instagram, and he wears like a full body LED suit, but he has like
Oh,
string LEDs throughout. So I messaged him and I was like, when I get this LED process perfected, you're like the first one, because that's exactly what I envisioned is a full body LED suit, and I actually want to have the fabric respond just like these panels. So yeah, it'd be a really a honor to work with him because he's doing exactly what I would imagine, this tech would be useful for. Ah, yeah, you found
yeah.
him. Look at this guy, it's
Yeah.
crazy.
Check this
You
out.
see that?
Look
Yikes.
at it. Whoa.
Amazing.
I would love to see this in action. You've commented on there. Yeah, wow. Tons of cool stuff. So we do, yeah, we have a question from Kamano again. I love the IR LED panel. Any way to get it on fabric instead of a board, which is kind of what you were just talking about, but also kind of not.
Yeah, so the way I'm trying to do it with on the fabric is either through capacitive sensors or ST
Mm.
has this thing called, what is it called? I can't remember the name of it, but it can detect living objects or objects that have a lot of water in them. So dogs, cats, people. And what I want to do is have an array of them such that it can get sort of like a general idea of where somebody might be standing within like a 10-foot radius of you, and then respond the LEDs in that kind of way. It's not super granular, but it's granular enough to have an effect. If somebody walking past you, you see the LEDs ripple across. So yeah, I'm working on having that as well.
That would be badass. Oh, let's see. So we've got a few minutes left. Let me see. There's so much more. Oh, you've got a couple more demos that we didn't get to. What's that
Yeah,
one that's standing up to your other side there?
this one here.
Yeah.
So yeah, this was the
Oh, right. You showed us that one already.
Bluetooth demo. Yep. But I
So
have some
cool.
other things here. I'll show you here.
Yeah.
So for the battery, oftentimes people have these little battery clips that they sew in. This here is a fully fabric battery pouch. You
Oh.
just pop a coin cell battery in that little slot, and then this can sew or snap on to whatever you have, and it'll power your circuit, completely soft. No need for solid components. Um, Also, these LED strips were made to be modular for like cosplay. If you wanted to get LEDs into your costume, you would just go to Digital Fiber Studio, click lines in the shape that you want your LEDs to be, export them, and then you just attach this controller. You can sew it or snap it on, and then you have a USB that you can sew or snap on, and then there's your full solution. You don't need any other external parts. So that's what that's for. Additionally, there are capacitive touch sensor. So if you wanted to make a turn signal bike jacket, you would go in a Digital Fiber Studio, draw your turn signal arrows, put that on your back, and you could have your capacitive touch here. Um, Here's a capacitive touch game controller. So each of these buttons has capacitive touch
Ha!
in them, and you can plug that into your ESP32 or whatever microcontroller you prefer. You have water sensor. I found that you can actually monitor somebody's breathing by covering their mouth with a water sensor, with the
Whoa.
moisture going out, and then is very different. So that works. And then there's some generic connectors. If you just wanted to connect your Arduino or whatever to something, a soft circuit, you just plug into this connector, and then you have your 4 leads there that you can sew into whatever you want to connect from there. Um, I've got a bunch of different PCBs. I think here's probably
Oh yeah.
So this is a LED matrix, which is just an XY grid. This is different than the Charlie plexing circuit. And this has an integrated controller. And the idea behind this was that you could talk to this controller the same way you talk to your addressable LEDs, and it would translate that into uh, the LED matrix. So you could use whatever library you're using already with your WS2812s, talk to this the same way, and then control LEDs. And that's using a flexible controller there. As I mentioned before, they're harder to work with, but they do provide the flexibility that a solid PCB doesn't. And that's sort of
Yeah.
yep.
You mentioned earlier, did I get this right? Before when we were talking before the show, does that microcontroller take regular LED commands and then translate them into Charlie plexing?
Yes. Yep.
That's so cool. And for people who aren't familiar with Charlie plexing, would you like to give a quick rundown?
Yes. So for there's two different techniques here. Matrixing is when you have an X and Y grid, and if you apply power to this Y column and ground to that X column, the LED where they meet is the only one that will light up. And the way you light up patterns is by cycling between these LEDs really, really fast, faster than what your eyes can see. So only one LED is ever on at a time, but you're switching between them so fast you can't tell the difference. Charlie plexing is similar to that. I don't know quite how to explain it, but the idea is that you use the fact that a LED is a diode. The D in LED stands for diode. Electricity can only flow one way. So you can arrange them in such a way that every combination of power and ground on these signals lights an individual LED. So this reduces the amount of traces that you need. In this case, you have 1, 2, 3, 4, 5, 6 traces, and you have 30 LEDs, where in this case, you have 60 LEDs, but you have 16 traces. So Charlie
Mm.
plexing reduces your trace count significantly, but complicates your circuit tremendously.
That's
That-
the best explanation of Charlie plexing I've heard. That's,
This here is actually Charlie plex as well. The
oh.
circuit inside of this thing is insane. So each of these, instead of using addressable LEDs as this one does, this is uses RGB LEDs. So each individual LED has a common ground, a R and a G and a B, and each R, each G, and each B is Charlie plexed with 63 other RGBs. So you have three Charlie plex circuits of RGB. You also have another Charlie plex circuit of the LED emitter, and then you have an array of the LED receiver. So there's a lot of Charlie plexing and array happen in this circuit here.
That's intense. That is so cool. Aisha has chimed in again. How do you power your larger LED wearable projects? Obviously, it's not all just coin cells.
Yeah, so the larger ones I use a battery pack, like the cell phone charging battery pack, and a USB. So I'll have somewhere here. I lost it. Here it is. I'll just pop this in somewhere and then apply USB power. So these large LED arrays, they don't draw, too much. You might get 600 or 700 milliamps, unless you're really driving them heavy. But you don't have to. I'll light them maybe to 30% at the most. Never really have to go
Hmm,
to 100.
nice. And then you've also got sensors often, like the motion responsive things, the infrared stuff, the turn signal jacket with touch sensing and stuff.
Hmm.
So, oh, sorry, go on.
Oh no, that was it.
Okay, yeah. So, really quick, I'd love to hear about some of the people who inspire you, or even like fictional things that inspire you when you're creating your work.
Yeah, I so this is kind of people. I'll start with people. The Lumia, there's a company Lumia.
Oh yeah.
Um, where they do e-textiles, but they use different method. They use like laminated methods. Yeah, there we go. And that's owned by a woman of color. She started that herself and has seen a tremendous amount of success with that. They did this really interesting glove that had a but is that it right there? That might be it. It had a bunch of sensors and like the fingers and stuff like that. And I just thought that was amazing. So that's she's a huge inspiration. And then you
Maddie
have
Maxey, she's so cool.
yeah. You have Geek Mom Projects. She's like one of the goats of LEDs. Who else does it? There's so many people doing LEDs. There's Jason Kuhn, I think his name is on Instagram.
Hmm.
He does these Fibonacci LEDs. So there's a lot of LED people who inspired me with the LED stuff. With the technology itself, I just liked it. Once I got exposed to it. Yeah, that guy. So that's
There's
an
lots of,
insanely complicated circuit.
oh yeah, this Fibonacci stuff.
Hmm.
And they've done some, like, for example, this Fibonacci LED thingamajig. I forgot what it's called.
Yeah.
I know it's got a name. It's like the Lumen something. I don't know. I feel like some people have done collaboration around this stuff, and I'm curious, would there be like a dream collab, just like completely out there, like either like a movie studio you'd love to work with, or an artist you'd like to work with, whether they're in electronics or not, or fashion or not.
Oh yeah. So
Horrible
like the
question.
the one dream that I have is so I want to use the ultra wideband technology with the LEDs. So I imagine a performer like Beyonce or somebody, and they have their stage
Yeah.
performer, and all of their lighted garments are interconnected with ultra wideband. And what you can do with ultra wideband is you can know your distance from every other person on the screen on the stage. And what that would allow you to do is do live light patterns with everybody's garment as one big screen. So when she sways to the left, all the LEDs sway to the left or to the right, or everybody in the crowd could have something on, and then they put a light show, a live light show through wirelessly connected devices. So that's sort of like a goal, and I have that as a goal because for me it's like if I can get to that, that means the manufacturing has reached a new height. The PCB
Mm,
design, everything would have to be at a certain level for that to be a possibility. So I have that sort of in my mind as what I'm working towards.
awesome. Well, we're almost at the end of our time here. I'm going to go back through all the links we've talked about, and I will be updating the description of the video with, for example, the Tindy page, the credit supply page that we were looking at. One final question. When you're getting your PCBs manufactured, you've got that colorway I love so much with the matte black and the gold, and oh, it's just so, like, to me, that's like the little black dress of electronics. I just love it. And who do you get to manufacture your PCBs? Do you have one that you stick with, or various different ones?
Yeah, usually JLC PCB, unless every now and then a new board shop will message you and say, "Hey, try us out." But it always led back to JLC. So shout out to JLC. They've improved quite a bit over the years. A lot. They do 3D
Nice.
printing now as well too.
Oh, cool. Oh yeah, I saw some of that stuff, and they've also started doing the full color uh, printing on PCBs, but you have to do it through
Hmm.
Easy EDA, I guess.
Okay. Yeah, that online platform.
Yeah, I still think the matte black is the coolest though. That's so good.
Yeah,
It's
I
so
love it.
pretty.
Yep. And it's
So
perfect for this kind of stuff too.
yeah, right. When it's like blends in, but it still looks so luxurious. Ugh. Um, so for people who might just be joining us, or like, let's just go back through it. So we've got your Instagram with a but. There's so many cool tips that you share on here, like the castellated dishes and stuff. Even this part about like you've got to like what project to start with and like starting. I won't spoil the ending because people should just watch it. But yeah, I thought that was really cool advice. We got your digital fiber Instagram. You on TikTok. We've got digitalfiber.us, the consultancy slash collaborative manufacturing thing. Um, I had an actual good phrase for this at the start. Wearable Design Studio. There we go. And then React LED panels. Sign up for updates on Crowd Supply. And then we've got digital fiber on Tindy. There's pre-sewn LEDs and things you can pick up. These textile capacitive touch sensors, which we did an article on a couple of years ago. You can read more about that. And also your GitHub and YouTube. So many different places to follow Rodney and learn from the amazing stuff that you're doing. Thank you so much for joining us, and I hope you have an awesome rest of your day. And thank you everyone else for joining us too.
Yeah, thanks for having me on. Thank everybody for tuning in. Look forward to anybody who wants to chat about it. Reach out if you need help or tips or anything like that. Nothing's a secret. I'll help you out with anything I know.
Awesome. Rock on or hack on, I guess that's the catchphrase, but